Okay, I'm doing this video basically to show a different way on how to balance a misbalanced pack. If you know me, then you know about the Balance Buddy, which is a nice, safe way to get access to the individual cells in the pack and balance them appropriately. We're going to start off with a perfectly balanced pack here. And then I'm going to purposely misbalance one of the cells in this pack and show you how to do a quick and dirty way of balancing it with this cable here. So just give me 1 minute and I'll get everything set up. Okay, basically I set my charger up to discharge one random cell in this pack. So I'm gonna go ahead and discharge this cell. It's currently at 4.187 volts, and so are the other cells in this pack. This is a perfectly balanced pack, but right now the charger is set up to look at one cell group so I can discharge it. So let me go ahead and get this set up. Okay, I set up to basically discharge a 1S pack, which like I said, I have the charger set up to look at one cell in the pack, and I'm gonna discharge it at 4 amps. So I'm doing this just to create a misbalance in the pack. So okay, just giving me a warning here. And now it's discharging the cell in the pack, and it should be discharging it at 4 amps. And I'm going to probably discharge about 500 milliamp hours out of the cell, hook the pack back up to the charger to show the misbalance between that one cell and the rest of them, and then show you how to find the cell and then use this special cable here to address that cell individually and charge it back up to where the others are. All right. I'll be back with you in a minute. Okay, so I've taken about 500 milliamp hours out of this pack, and so right now the voltage is rebounding. So that cell that was at 4.18, 4.19 is now at 4.11, 4.117. So right now it's still hooked up to the charger and everything. So I'm going to show how it will look like if you were just spot checking the pack and notice that you had a misbalanced cell. Okay, so I have a cell log here and I plugged in to the balance tap of the pack that I misbalanced. And so we have cell 1 through 6 with cell number 4 being out of balance. So there's about a 65 millivolt deviation on this pack. So what will tend to happen is if I were topping off this pack, you would have cells at like 4.2, and then you'll have that low cell at like 4.15. And if with most generic chargers, like the older iChargers and iMaxes and everything, to get rid of that 500 milliamp hour balance misbalance of the cells, it would take anywhere to 3 to 5 hours. So this is one way that I'm going to show you on how to identify the correct cell that's misbalanced. Use this cable to probe it at the balance tap, and hopefully we can boost that cell up to where the others are. All right, so give me 1 second, I'll get everything set up. Okay, I have the pack plugged up to the charger, and again, we see all the cell voltages with cell number 4 being the lowest cell and the cell that's misbalanced. So this is just another example of how it would look like on a charger versus the cell log here. Okay, so that now we've identified the weak cell in the pack is now we have to figure out which cell it is on the balance tab. Now I checked it with the cell log and with my charger here, and it said it was cell number 4. So what you do is you want to flip the balance tab over until you see the metal contacts. The balance tab has a positive side and a negative side. To locate cell number 4 on the balance tab, what you do is you start from the right, which is the negative side, and then so you count the first one. So the black is number 1. The one next to it is number 2. The one next to that is number 3, and the one next to that is number 4. So this is where you will put your negative probe of the harness to locate cell number 4. So let me do that now. Okay, so now we have the negative probe plugged into cell number 4. So if you count from the bottom, which is the negative side of the pack, so we get 1, 2, 3, 4. The negative goes right there. All right, so now we need to connect the positive lead. So you plug the positive lead right next to the negative lead. So it will be the 5th slot. So let's go ahead and plug that in. Okay, so now we got the positive lead plugged in. So we're now plugged into cell number 4 of this pack, and there's the voltage right there. It's sitting at 4.11. So we've identified the correct cell that was misbalanced, because if you remember, the rest of the cells were at 4.17, 4.18. So we are on the correct cell. So now we can address this cell directly with the charger and charge it as a single cell. So let's go ahead and get that started. Okay, so I'm charging, and let's go ahead and tab over. We're going to ignore capacity. We want to make sure your charger is set up for one single cell. If you had, or if you used a BC168, you can charge up to 8 amps through the balance tap, but we're going to be conservative on this. So let's go ahead and change this to 4 amps. And just to get it ultra precise, we're going to go ahead and do a slow balance on this. We're going to do a slow balance on this pack, and what this does, it ensures the cell gets a full complete charge, and it terminates the charge at 1/10 of the original charge amperage. So this one should terminate the charge when the cell stops accepting current below 40 milliamps. So let's go ahead and get this started. So right now we're about to start charging through the balance tap that misbalanced cell in this pack. And since I roughly took about 500 milliamp hours, it should put about the same amount back in, plus or minus a certain amount. So what we're doing is we're basically catching up that weak cell or that misbalanced cell to the rest of the pack. And what this allows you to do is, instead of the charger working so many hours trying to balance the pack, we got it much closer than it could get by itself, so that whenever you go to balance the pack or charge it again, it's the balance of the pack is a lot closer, and it can terminate the charge a lot more quickly since it's not working to struggle. Since it's not struggling to catch that cell back up, because most chargers have about a 100 to 200 milliamp balance shunting shunting current. That means it can bleed out about 200 milliamps of current to bleed the cells down to allow the other cells to catch up while it's charging. Now this charger right here has a 2.1 amp balance current, so the problems that other people have with weaker chargers, I don't have that issue. This charger can knock out a misbalanced pack in no time, but you know, some of the older RC chargers or the less expensive one doesn't have the capability of this one. So I'm just doing this video just to show the underlings how to do it appropriately. Now, to make this cable, all I did was disassemble a extension cable that had the pins that I could slide out, and then I soldered 4mm bullets to the other ends to where it can plug into the main port of the charger. Let me just grab the balance cable just to show you what I'm talking about. Okay, so here we have a balance extension cable, and so all I did was pull the pins out of this end, and it will give you a needle type pin that you can probe these connectors, the JST balance connector, and then to get it out of this end, you can just either simply cut it, or you can depress the tab that's right there and it should slide out. Solder it together, put heat shrink on it, and there you have it. You have a nice, cheap, easy to use balance cable. Now, when using this cable, preferably you want to plug this into the charger first before you start probing the cells, because if you plug it into this first, you will have two bare ends, and then they could possibly touch each other and spark. And that's what you don't want that. So you want to probably plug this into the charger first, because the ports of the charger are normally isolated and deactivated. So even if I unplug this and touch the wires together, it won't spark. So you can plug this in first and have these ends loose, and it won't cause an issue. So this is the safer way to do it. Plug the cable in first before you start addressing the balance tap, and then also be very careful when inserting the pins in. There's no real danger, but like I said, if you did it the reverse way, then you'll start getting sparkage. Here we are with 81 milliamp hours in, so I'm gonna go ahead and cut it right here, and then pick back up when it's finished charging. Okay, it just got done charging up that cell. It didn't quite get to 500 milliamp hours, but it's pretty darn close. It's at 4.176. So I'm gonna go ahead and disconnect everything and plug the pack up back to the charger to see how close did it close the gap. Okay, so this is how it looks like with the pack plugged back up to the charger. It's not directly in line with the others, but it's pretty damn close. Before it was 65 millivolts out of balance. Now it has reduced it down to 6, this is very manageable for any charger. So I'll consider this pack back in balance. But in case I wanted to get it, you know, perfect like it was before, all I have to do is put this back in the balance mode on the charger, and it will get it back in balance. So I'm gonna do that right now. Okay, so I'm gonna go ahead and just start another balance charge. Make sure I change it back over to 6S. Okay, I'm starting this back up. And again, it didn't take that long to bring that cell up. But like I said, I'm just doing the final balance on it just to bring it perfectly back in line with the other cells. And once I get done with this, it shouldn't take no more than 5 or 10 minutes versus the several hours that it could have taken trying to balance it the normal way with cheaper chargers. So we're just gonna go ahead and let this get done. There's the time right there. Let this finish up, and that should conclude this video shortly. Okay, after about 6 minutes of charging, the pack is back in perfect balance. Again, this was very, very simple. You don't need the balance buddy. You could probably make this yourself. So that concludes this video, and thanks for watching.